guys, today we are going to discuss OSPF. In OSPF, in previous class, I told you something basic about the OSPF, right? OSPF is the dynamic routing protocol, right everyone? OSPF is the dynamic routing protocol. There are two types of routing protocol. First one is static routing and second one is dynamic routing. In static routing, as an administrator, you have to define the best path on a router, right? And whatever you define, and router will choose that path to send the packet, right everyone? But in case of dynamic routing, we just configure the dynamic routing protocol. Fine. And on the basis of that protocol, router will choose the best path where to send the packet. Getting my point, everyone? That is dynamic routing. In dynamic routing, there are multiple type of algorithm, there are multiple types of rule, and on the basis of that rule, router will take the forwarding decision. Done, everyone? Are you telling me?
Yes.
Now, what is the first point I written here? OSPF is a open standard, which means we can run this protocol on any vendor device. Right, Anna? I think in previous class, I told you this thing. Right now, there are two types of protocol. First one is open standard and second one is Cisco proprietary. So Cisco proprietary means that protocol is developed by Cisco, or you can say Cisco is the owner of that protocol. Fine, na? But what do you mean by open standard? Open standard means this is open for all vendor. Getting my point? So this protocol you can configure. OSPF is the open standard. It means OSPF will support on every vendor device. The next one is OSPF operates at layer number 3. In OSI model, there are multiple layers. We will discuss OSI model later. In OSI model, there are how many layers, guys? 7 layers. Getting my point? At layer number 3, what is the name of layer number 3, guys? Network layer. Fine. And at network layer, your IP address works. Okay. So OSPF operates at which layer? Layer number 3.
Layer number 3.
The third point, OSPF used the protocol number 89 in the IP header to identify it. Yes, at layer number 3, when I explain you the OSI model, I will show you at layer number 3, there is which protocol, guys? IP protocol. And for IP protocol, there is a IP header. In IP header, there is a field called protocol number. What is protocol number? And for OSPF, what is the protocol number? 89.
89.
So please remember this one. Next one, OSPF use basically two types of multicast address. First one is this one and second one is this one. Fine. Basically, when you configure the OSPF on a router exchange some information with each other. Router start exchanging some information with each other. Getting my point? For example, what I'm trying to say, try to understand. This is the router number 1 and this is the router number 2. On router number 1, I configure the OSPF, and on router number 2, I configure the OSPF. For example, source IP is 10.1 and here it is 10.2. Let's suppose R1 is sending the packet. What will be the source IP address, guys? 10.1. What will be the destination IP address? Multicast IP address 224.0.0.5. Getting my point, everyone?
Yes.
So this is the meaning of this address. So please remember this line. OSPF use multicast address for communication. Understand, everyone?
Yes.
OSPF use multicast address. Now, there is two address 224.5 and 6. All the OSPF router use this address to communicate with each other. This is the multicast address for OSPF message to need to reach all the router. It means all the router will listen this address. And 226 means this address is specifically OSPF router to send the information to the DR. To the DR, or you can say only DR listen this address. See, what is the meaning of this line? In OSPF, if let's suppose there is a one switch, and through this switch 1, 2, 3, 4, 4 routers are connected. So guys, tell me one thing. Here I assign 10.1, 10.2, 10.3 and 10.4. Is it fine or there is something mistake? This is fine?
This is okay.
Yes, this is okay. There is no problem. Because this is the switch. And all the devices connected with the switch in the same network, right? Na? LAN network. Are yes, na?
Yes.
So that's the reason
Yes.
on all the router I configured the same network IP address. Fine. Now tell me one thing. Here I configure the OSPF, and OSPF. Fine. In dynamic routing, I told you what router will do. Router start exchanging the information with each other. Yes or no?
Yes.
Let's suppose R1 has its own routing table, or you can say database. Okay. R1 has its own database. It means all the router have its own database. Yes or no? Router number 3 also has its own database. This router has database and this router has database. Yes or no? Yes. Every router maintains its own database. Okay. Why do we need so many? I'm just giving you the example. I'm just giving you one example. See, if all the router have its own database, it means, and when you configure the OSPF on all the router, what R1 will do? R1 share its complete database with R3. R1 share its complete database with R4, and R1 share its complete database with R3. Yes or no? Everyone. Yes, na?
Yes.
Because all
Yes.
is in the same LAN, or you can say all the router is in single multicast segment. It means there is only one segment, right? Anna? Now, similarly, now tell me one thing. R3. R3 have its own database as well as R3 receive one database from R1. Yes or no? Yes, na? So
Yes.
it means now R3 have how many database? Two database. Its own database and R1 database. Yes or no? Yes? What R3 will do? R3 will share the same database with R4, R1, R2. It means now come on R4. R4 has how many database? On database. R4 already received one database from R1. Yes or no? Now
Yes.
R4 received one database from R3. How many database? R3 database as well as again R1 database. Yes or no? Yes, na?
Yes.
Everyone. Now, come on R2. Again R2 will share on database as well as R2 already received the R1 database. R1 receive the R3 database and R3 receive again R1 database. Why R3? So R2 share this database again with all the router. It means every router has multiple duplicate database. Yes or no? Everyone. Yes, na?
Yes.
R4 already receive R1 from R1. R4 receive R1. Why? R3. Again R4 receive the R1. Why? R2. Yes or no? Yes.
Yes.
So this is the problem. This is the problem. Why this is the problem? Because see na, every router has multiple database right now. Right na? So if these router maintain multiple database at a time, so definitely the load on the router will be quite high. Yes or no? Yes. So what is the solution? The solution is to solve these type of problem. What we will do? We will select among all the 4 router, one router will be guys leader. One router will be guys leader. Okay. And all the other router, these are not leader. For example, R1 is leader and these are non-leader. Yes or no? So what non-leader will do? Non-leader always share its complete database or any update with the leader only. These router do not share the update with its neighbor. Its neighbor. Getting my point, everyone? Do you guys understand what I'm trying to say? Everyone.
Yes.
So in OSPF, the leader is called DR. What is guys? DR. Getting my point, everyone? So that's the reason I written there 2 type of multicast address, 224.0.0.5. Basically, this address is listened by all. For example, if you configure the OSPF and if you ping from here to here or here to here or any router, what will be the destination IP address? 224.0.0.5. It means for general communication, the destination IP address will be this one. But if these router wants to share something with DR, these router will share the destination IP address. These router will use the destination IP address 224.0.0.6. Done na? Everyone. I hope these things clear to all of you. Right? So 224.0.0.5, this is for normal communication, and 224.0.0.6, this address OSPF router use to share any information with DR. It means you can say this address who can listen? Only DR can listen. Only DR can listen this address, and this address can listen all. Done na? Everyone. Can you tell me?
Yes.
So basically, this is the difference between 224.5 and 224.6. OSPF use the SPF algorithm. In previous class, I told you, right? OSPF use the SPF algorithm to choose the best path. Fine. Next one is OSPF use what is the AD value, guys? 110. And I told you what is the use of AD value? This represent the trustworthiness. This represent what? Trustworthiness. Right na? Lower value always be trusted. Or you can say lower AD value always be prefer. Right na? These things I already explained you in the previous class.
Yes.
Now, the next thing, how to configure OSPF on a router. What are the command? See, first command I write router OSPF. If you remember in previous class, after write the router OSPF, I press the question mark, then I get this one. Yes or no? Yes,
Yes.
na? What do you mean by this? This is the process ID. What is, guys? Process ID. And what is the range? This one. Now, if anyone asks you, sir, what do you mean by process ID? What is the use? So just tell him one line, process ID is nothing. By the help of process ID, we can just separate the configuration on the router. Getting my point, everyone? Just separate the configuration on the router. For example, this is the router one, and here you write OSPF router OSPF 100, and here you write network 10.0.0.0, and then here you write wildcard mask and area is 0. So it means this configuration you did where? In process ID 100. For example, on the same router you write router OSPF 200, and here you write network 20.0.0.0 wildcard mask and then area 0. So on the same router, how many configuration you did? 1 and 2. 2 configuration you did. Yes or no? Yes. But these 2 configuration are separate. These 2 configuration are not one. Getting my point? Why? Why both configuration are separate? Because you configure the different process ID. You configure the different process ID. So it means on a single router, what you can do? You can configure the different configuration and you can separate that configuration with the help of process ID. Done na, everyone? But in case of EIGRP and OSPF, when you write router EIGRP and then press question mark, what you are getting the AS number. Yes na everyone? Are what you are getting?
Yes, sir.
AS number. So AS number is different and process ID is different. Are you getting my point, everyone? Yes or no?
Yes, sir.
And so when you write the process ID, the next thing is you have to write this command network. After network, what you need to mention, guys? You have to mention what? Network ID. Either you can write the complete network ID or either you can write the IP address. Are you getting my point? What I'm trying to say? Everyone? No? See. For example, this is the router 1. On this router, 1, 2, 3. Here I configure 10.1. Here I configure 10.2. And here I configure 10. Sorry. Is this possible?
No.
Here I configure 20.1 and here I configure 30.1. So what is the meaning of this? When you write the network command, and there are 2 options, either you can write the network ID or either you can write the IP address. So basically, what is the use of this? Basically, by the help of network command, so please remember this one, by the help of network command, we are just advertising the network or IP in OSPF. If you are writing network 10.0.0.1, then write the wildcard mask and then write the area. And you can write like this 10.0.0.0 wildcard mask and the area. What is the difference? Here you advertise the particular IP address in a OSPF. Yes or no? Yes, na?
Yes, yes.
Here, what you are doing? You are just advertising the particular IP address in the OSPF. And here, what you are doing? Here, you are advertising the complete network in OSPF. Getting my point? So basically, that is the difference. So either you can mention the network ID or either you can mention the IP address. In real scenario, generally we are focusing on IP address, not complete network, because you know network is big. Network is big. So we cannot take the risk. So that's the reason we are choosing the IP address, not complete network. Then guys, wildcard mask, you have to mention the wildcard mask. And when you configure the wildcard mask, then you have to mention the area. Getting my point? So what is the command to configure the OSPF? First, define the process ID. And when you configure the process ID, you need to configure the network command. What you need to configure, guys? Network command. Are you done now, everyone?
Yes, sir.
Okay. I think in yesterday class, someone asked me, sir, what is the use of wildcard mask here? So see, here I write this what is this? This is the wildcard mask, na? Yes or no?
Yes.
Yes, everyone. This is the wildcard mask, and this is what? This is the network
Network
ID.
ID.
And this network ID belongs to class ABC. Which one? Class
C.
C. So for class C, what is the wildcard mask? Arey,
0
subnet
.0
mask is
0 2
255. So wildcard mask will be 000255. Yes, na? Everyone. Yes. So that's the reason I write here 000255. Arey, yes, na? Everyone tell me.
Yes.
Right? See, it means match the first 3 octet exactly and ignore the last octet. So that is the meaning of wildcard mask. It means OSPF, whenever this router, when you configure this one on a router, whenever router get the packet, router match these 3 bit. These 3 octet. Only these 3 octet. Getting my point? Are tell me yes or no?
Yes, sir.
Yes, sir. And last one, this one, 0 will be ignored. And router will take the forwarding decision on the basis of these 3. Clear, na? So basically that is the use of wildcard mask. And if you mention, let's suppose I write the IP address 192.168.1.1. So it means you mention what? You mention the exact
Same
IP
ID.
address here. Yes or no? Yes, na? Everyone.
Yes.
For example, when you configure the IP address, you see na what is the subnet mask /32. Right na? In previous class we discussed. Right na? I show you in the routing table, you guys see na the /32. It means, for example, 192.168.1.1. So if you are assigning this one, then you have to mention the CIDR value of how much? 32. Are you tell me yes or no? Yes, na? So for 32,
Yes.
what will be the wildcard mask? 0, 0, 0, 0. This one. It means in this case, OSPF will match each and every octet. Are you getting my point? Yes, na? Now
Yes.
OSPF will match each and every octet, and on the basis of this, OSPF will take the forwarding decision. Then, now the most common question in the interview, what is the use of network command? What is the use of network command? So basically there are 3 use of network command. First one is it defines the area. Whenever you are writing the network command, you are writing the area 0, area 0, area 1, area 2 like this. So it means you are defining the area. So this is the first use of network command. It defines the area. Second is it advertise IP or network in the OSPF. You are writing network and then either you are writing the network or either you are writing the IP. It means you are just advertising IP or network in the OSPF. Getting my point? So that is the second use of network command. And the third one is the interface on which advertise the network is assigned will join the multicast group. What do you mean by this? It means for example, this is the R1, this is the R2. On R1, I configure the 10.1 and here I configure the 10.2. Here I configure the OSPF. Here I do not configure the OSPF yet. After writing the command router OSPF 100 and I write network 10.0.0.1, wildcard mask is 0.00 and area is 0. So it means when I configure this command on R1, it means now OSPF is configured. Yes or no? Everyone? Yes?
Yes.
It means when you configure the OSPF, immediately router starts sending the packet. When you configure the OSPF on a router, immediately router starts sending the packet. This router starts sending the packet. First packet is the hello packet. Which packet, guys? Hello packet. Are you getting my point? Everyone?
Yes.
Router starts sending the hello packet. Fine. In hello packet, what will be the source IP address? 10.1. What will be the destination IP address? 224.0.0.5. Yes or no? Yes.
Yes.
This is the unicast IP and this is the multicast IP. Yes or no? Yes. This hello
Yes.
packet reach on R2 this interface. When this packet will reach on R2 this interface, and if you do not configure the OSPF here, this router do not understand your packet, hello packet. Not understand. The reason is when router open this packet, router number 2 will open this packet, router number 2 will find destination IP address is this one, and that is multicast. That is multicast. And by default, router cannot understand the multicast packet until and unless you do not enable the multicast. Until and unless you do not enable the multicast. Are you getting my point? Yes or no?
Yes.
So that's the reason when you configure the OSPF here, this router sending the hello packet, but this router do not accept it. The reason is this router is not able to understand the multicast packet. So it means what is happening here, try to understand when you configure the OSPF here, and let's suppose when you advertise this 10th network in the OSPF, then router number 1 will check. You already advertised not 10 network in the OSPF, everyone. Yes?
Yes.
So this router will check this 10th network is configured on which interface. Then this router will find this 10th network is configured on fast Ethernet 0/0. Immediately this router enable the multicast feature on this interface. Multicast feature, or either you can say this router join this interface as the part of multicast group. Getting my point, everyone? So this is the third use of network command. When you advertise any interface or any network or any IP address in the OSPF, router check that IP or that network is configured on which interface. Fine. And once router will find the interface, router join that interface is the part of multicast group. So when this interface will join the multicast group, it means now router number 1 is able to receive the any multicast packet on this interface. It means through this interface, router can receive the multicast packet. But here you still do not configure the OSPF. So that's the reason this router is not able to understand your multicast packet. When does the router forward the multicast? When you configure the OSPF. When you configure the OSPF, let's suppose you write the command router OSPF 100. When you write only this line on R1, router number 1 never share the any hello packet because hello packet is the multicast. It means when you write this command, by the help of this command, router interface do not join multicast group. If you want to join the multicast group, you have to write which command? Network command. Understand?
Yes.
Everyone. Tell me.
Yes, sir.
I mean to the other router. On other router, you must need to configure the OSPF and advertise the network. Then this router is able to understand your OSPF messages. Otherwise, no. Done? Everyone.
Yes, sir.
So I hope now you guys understand what is the use of network command. So there are 3 uses of network command: define the area, advertise the network, and join the multicast group. Done na, everyone? This is the very important interview question. Once you configure the OSPF router, start exchanging the hello messages. Done? Note, if you do not configure the network command, router will not generate any OSPF messages. Done na, everyone? It means,
Yes.
let's suppose if you configure the first part of the OSPF, if you configure only router OSPF 100. So in this case, router do not share any OSPF messages. Router will share the OSPF messages only when you configure the network command. Getting my point? So when you configure the network command, the router interface will join the multicast group. And once the router interface join the multicast group, then router can send the hello packet and receive the hello packet. Otherwise, no. Done na? Everyone, tell me.
Yes.
The area. You mentioned the area. That's the first thing it defines. It defines the area.
Area.
Now, yes. Now, please, can you come again? Because I just joined not quite long. That area, how do we know that area? Because I
Area
know
means, for example, this is the R1, this is the R2. When you configured router OSPF 100, then write network, then IP address, then wildcard mask, then you need to define the area. For example, let's suppose this router belongs to area number 0. So then you write here area 0. It means, for example, there will be any scenario. For example, this is the router and these are the two interface. Here you are running the 10th network and here you are running the 20 network. And you want this 20 network will be the part of area 1 and this will be the part of area 0. What you will do? You need to write the command network, then 10.0.0.1, then wildcard mask. Yes or no? Everyone, tell me.
Yes.
yes.
0.255.255. Then 10th network belongs to which area, guys? Area 0. So I write area 0. Network 20.0.0.1 0.255.255.255 and define area 1. So basically, by the help of network command, you can define the area. Understand? So that is the second use of network.
Okay.
In this we are giving IP address, so why we are not putting wildcard to 0.0.0.
Yes, you need to write the 0000. I'm just write the example, but you need to write the /30. Done. And generally we are writing 0000 because we want OSPF match all the octet for more accuracy.
Okay, sir. Thank you, sir.
Okay. In previous class, I already explained you the wildcard mask. Right, everyone? Tell me. Right, na?
Yes, sir.
For /8, what will the wildcard mask? You guys tell me.
0.0.0.255.
The white cards will be 0.0.0.1. 0.0.0.0. No, you know,
0.255.
0.255.255.255. That will be the wildcard.
255. Sorry. Okay.
And what is the wildcard mask for /27, guys?
That should be
Exactly.
for
000.
reverse of this. Okay.
You guys can watch the previous video. I think in previous video we covered this one. Right now, everyone. Process ID I already told you.
Yes.
Now, OSPF is the IGP protocol. I hope everyone is aware about it. Right now, there are two types of protocol, IGP and EGP. IGP means it works within a single AS. Yes, na? And EGP means it works.
That's within
If you want to get
AS.
communication possible in the same AS, what you have to run? IGP or EGP?
IGP for the same area.
EGP. And for different AS, we need EGP.
EGP.
EGP. OSPF is the IGP, which means it operates within the same AS. OSPF
Area.
router do not
Yes.
use the AS number. I told you in the previous class. Right now, OSPF router use the process ID.
Process ID.
EIGRP and BGP use the AS number. Right now, everyone? Yes or no?
Yes.
Yes, yes.
To manage a large network, OSPF divide one AS into a small part that is called area. Right now? And when you divide the AS into a small part, what will happen? What is the benefit? Benefit is to reduce the size of routing table, to reduce the load on the router. Right now, everyone?
Yes.
Tell me. So that's the reason in OSPF we have a concept of area. If
Area.
any interviewer will ask you this type of question, tell me why OSPF use the area. How can you answer? You can say कि in OSPF there is no concept of AS number. It means all the roots or all the prefixes belongs to the same AS. Right na? So it means
Yes.
if we have a single router, then definitely the load on that router will be quite high. Getting my point? And maybe our routing table will crash. So to avoid these type of situation, we have a concept of area, and by the help of area, what we can do? We can divide our AS into small parts. Fine. And it helps to reduce the size of routing table as well as to reduce the load on the router. The exact line you have to tell to the interviewer, and an interviewer will happy. Done, everyone? Understand?
Yes.
Now, we know EIGRP is the IGP protocol, does not use AS number. In previous class, I told you as well as I show you. Right now, router EIGRP, and then I press the question mark. Then what you guys will get? AS number. Right now? So EIGRP is the another IGP used to find the best path within the single AS, similarly to the OSPF. However, EIGRP uses the AS number to distinguish between the different instances of EIGRP running on the same router or same network. But in case of OSPF, we have a concept of area. We have a concept of area. Getting the point? But again, interviewer will ask you one question here. The question will be, if you configure the router OSPF 100 and router EIGRP 100 on the same router, how do these configuration differ and how do they affect the neighborship like this? So try to focus here. When you configure the router OSPF 100, this means this is the process ID, right everyone? Right?
Yes.
And what is the use of process ID? By the help of process ID, we just separate our local configuration. Yes, na? For example, on router number 1, if you configure router OSPF 100 and then you write the network command and you advertise the 10th network. On the same router, let's suppose you write router OSPF 200 and you write the which command? Network 20, you advertise the 20. Are you getting my point? Yes or no? So it means on the same router, how many configuration you have? 2 configuration you have, right? And these 2 configuration is separated by process ID. Are you getting my point? Yes or no? Everyone?
Yes, sir.
Are you tell me? Understand? So if anyone asks you the process ID, what you can say? Process, by the help of process ID, what we can do? We can just separate the local configuration of the router. We just separate the local configuration of the router. The process ID does not need match between the routers to become the neighbor. It means if there is a R1 and there is a R2, if on R1 you configure the process ID 100 and if on R2 you configure the process ID 200, it will not impact on the neighborship. It will not impact on the neighborship. Neighborship will form. I think in previous class I saw you also. Right now, everyone. Are you tell me?
Yes, sir.
Yes.
Yes. On one router, I configure router OSPF 100 and on another router, I configure router OSPF 200. And then after configure the OSPF, and I write the command, what? So, what is the command? To check the neighborship. Who can tell me? So, IP OSPF, neighbor.
Neighbor.
Right now, and you are getting the result, it means neighborship is established. But when you configure the router EIGRP 100 and the number 100 is what? AS number, right now everyone? When you configure
Yes.
router EIGRP 100, it means what is 100? 100 is AS
Yes.
number. Fine. Now,
Yeah.
the AS number is the
Yeah.
EIGRP must match between the routers to become
Who does the
the
repeating?
neighbor. It means if you run OSPF 100 and OSPF 100, this is the router 1 and router 2. Here you run router OSPF 100, router OSPF 200. Both router will become neighbor. There is no problem. There is no problem. But this is R1. This is R2. Here I run router EIGRP 100 and here I run EIGRP 200. This is what? AS number. Right now everyone? This is AS number. So in this case, neighborship will not form. So please remember this one. Do you guys understand? Yes or no?
Now,
Yes, sir.
the second one said,
Yes.
why would that happen? Okay, it's supposed to be if they are going to work, that means the second one should be like the same value, the same AS number, right?
Yes, basically when you have a concept of AS number, then two router will become the neighbor when both router will be in the same AS only. Because
Yes,
AS
yes.
means what? AS means you are just defining the administration role, or you can say zone, I told you. Right now?
Zone,
In
okay.
same zone, it will become the neighbor. In case of same
Okay.
OSPF, let's suppose if router 1 is the part of area 0 and router 2 is the part of different area 1, both router will not become neighbor.
Not become neighbor, yes, okay. Yeah, yes, true.
Understand? Everyone.
True.
Yes, sir.
But for BGP, they can become neighbor, right? If it's BGP. If they are different AS number.
In case of
BGP,
BGP, the concept is completely different. In case of
right.
IGP protocol, neighborship will form dynamically. You do not need to tell on this router okay, this is your neighbor and on this router this is the neighbor. No, we are not doing like this. Right now, you just configure the OSPF here, you just configure the OSPF and both router become the neighbor automatically. Both router exchange some packet. In packet, there are some parameter. When all the parameter will match, both router will become the neighbor. And all the thing is happening automatically here. Either in case of OSPF or either in case of EIGRP. But in case of BGP, this is not similar. In case of BGP, neighborship is statically. Statically means on this router you have to tell that this is your neighbor, and on this router you have to tell manually that this is your neighbor. So that's the reason I'm telling. In case of BGP, the concept is different. Done na everyone? Are tell me?
Yes.
Okay. Do you guys know how to configure the loopback and what is the use of loopback?
No, sir.
Loopback address is 127.0.0.0. That's the value of loopback address.
Yes, basically, see guys, there are two type of IP address we are assigning. One we are assigning on the physical interface, and there are one more type of IP address we are assigning that is called virtual IP. Okay, and that is called loopback. Fine. For example, this is the router. This is the router number 2. Here I assign 10.1 and here I assign 20.2. I can ping from R2 to R1, R2 to R1 to R2. Right now, here you can ping 10.2 and here you can ping 10.1. Yes or no? Yes,
Yes.
no, everyone. For example, I want to ping something there. I mean, in this area and in this area. So what you have to do? Either you have to install any PC or any network. Are yes or no? Yes, na? Either you have to configure or either you have to install any device. Then you can ping from here to here or here to here. Yes or no? Everyone?
Yeah.
Yes.
Yes. But by the help of loopback, we do not need to install any physical device. Fine.
Oh.
So on router number 2, what you can do, you can configure any loopback address. Fine. And that is the virtual IP address. That is the virtual IP address. You do not need to configure or install any physical device. So basically, loopback is used for the testing purpose. What is, guys? Testing purpose. Done? Everyone understand?
Yeah, that means for troubleshooting. Can you use it for troubleshooting as well, right?
Yes. Generally, we are configuring the loopback for troubleshooting purpose, or it helps in the troubleshooting for testing purpose. Okay. So how we configure the loopback? Same way, interface loopback, fine, and I press the question mark. It means after that you have to write the interface number. So this is the range. Now you guys can calculate it. What is this? I think this is in log. So after that you have to write the loopback number. For example, I write the interface loopback 1. Fine. So now we are in which mode? We are in interface mode. Which interface mode? Loopback interface. Here you have to write IP address. For example, I am writing 1.1.1.1. Fine. Then after that, I press the question mark. What is this? Subnet mask. So what is this? 255.255.255. Because all the octet is completely filled. Yes or no? Are you tell me?
Yes.
Yes, na? So it means that is /32, right? Na? Everyone. Then no shutdown. Generally, I'm writing no shutdown. This is my habit, but generally, when you configure the loopback address, you do not need to write no shutdown because it is automatically up. Right, na? Everyone.
Yes.
Again, I'm writing interface loopback, for example, 2. I'm writing the IP address 2.2.2.2, 255.255.255.255. And then no shutdown. Sorry, this is my habit, but if you want, you guys can write, otherwise ignore. What is the command to check the IP address is configured or not? Do so IP interface tree. On 0/0, I assign the 10.1. This is statically up. And on loopback, I configure 1.1, and loopback 2, I configure 2.2.2. Right now, and it is automatically up. Getting my point? Everyone, yes or no? Yes.
Yes.
On this router, then everyone, tell me. When I
Yes.
configure here, I do not write the no shutdown command. See, it's automatically up. Okay. So on R1 and on R2, I configure the IP address. Yes or no? Yes.
Yes.
Now come here on R1. I need to check, is there any protocol is configured? What is the command? Do so IP protocol. I'm not getting any result. It means right now, one of the protocol is configured here on R1. Yes or no? Everyone tell me. Yes, na? Are you tell me, guys? Everyone. I don't know in packet tracer OSPF will support or not, but I'm trying first time. Hey, everyone tell me, is there any problem? Till now, I hope you guys understand. So
Yes, sir.
on R1, I'm not getting any result. It means right now, none of the protocol is configured on R1. Okay. I'm going to configure OSPF. What is the command? Router OSPF, then process ID. Yes, na? Everyone,
Yes.
100. Okay. And after that, what you need to do?
Network.
You need to write which command? Network command. Network. See now, when if you do not write the network command, if you write only router OSPF 100, this router never share any messages. This router never share any messages. Why? Because this interface not join the multicast group. They understand everyone? Yes or no? This
Yes.
interface do not join the multicast group. So what you need to write, guys? Network, and after that you need to write what? Are you tell me? Network number. So on 0 by 0, what I assign? 10.0.0.1. Yes or no? Everyone tell me.
Yes.
Yes. 10.0.0.1. And after that, wildcard mask. So this is from class A. So what is the wildcard mask, guys?
0.25
For IP address, we are assigning the slash 32. And then, guys, you need to define what? Area. Area is 0. See, when I press this one, automatically this router generate one packet. Yes or no? Yes, na? After writing the
Yes.
network command. Tell me. After writing the network command. Fine. And tell me everyone, yes or no? Yes, na? And I told you OSPF is a which layer protocol? Layer 3. And tell me, layer 3, na? So see, this is the OSPF hello packet. And after hello packet, what is this? IP header. Right, na? That means it belongs to
Yes.
layer number 3. Tell me everyone, yes or no? So tell me one thing.
Yes.
Open this OSPF packet. Hello packet. What is the source IP address? 10.0.1.
And 1.
What is the destination IP address?
224.05.
That is multicast.
Multicast.
That is multicast. Understand everyone? I told you these things.
Yes.
Okay. And this is the OSPF hello header. In hello header, you guys get OSPF router ID. What is router ID? We will discuss these things later. Area is
0.
0. You assign now already. Area 0. And area is always written in the decimal format. So that's the reason it is looks like 0000.
0, 0.
Okay, na? Network mask is this
2
one.
Papa.
Hello interval is 10. It means after every 10 seconds, when you configure the OSPF, router exchange the hello packet. Router exchange the hello packet. After how much time? After every 10
10
seconds.
seconds.
That's the reason hello time is 10 seconds. So that's the reason hello packet is also known as keep alive message. What is keep alive message? What is the reason? Because if any router do not receive the hello packet, then for example, this is the router 1. It means router number 1 will share the hello packet after every 10 seconds. Getting my point? And router number 2 will share the hello packet after every 10 seconds. It means both router is exchanging each other's hello packet after every 10 seconds. So it means both router already know my neighbor is alive, and this router know my neighbor is alive. Yes or no? Yes.
Yes.
So that's the reason hello packet is known as keep alive message. Done now everyone. But for example, this router do not receive the hello packet from this router. So it means in this case, this router will wait. How much time? 40 seconds. How much time, guys? 40 seconds. And if this router do not get the hello packet from its neighbor till 40 seconds, then this router will understand definitely my neighbor is down or my neighbor is dead. Getting my point? And that 40 seconds is known as which time? dead time. Which time, guys? Dead time.
Right.
Are you understand na, everyone? Dead time
Yes,
means,
sir.
what is the dead time? 40 seconds. It means router will wait till 40 seconds. If in 40 seconds router will not get the hello packet, router will assume my neighbor is now dead. Are you understand, everyone? Yes or no?
Yes, sir.
Yes.
See, this router send the hello packet to this router. What happened? This router drop this packet. What is the reason? Because on this router
Multicast is not. Sorry.
enable the OSPF. And
Yes.
if you do not enable the OSPF on this router, this interface still do not join the multicast group. Yes or no? Can you tell
Yes.
me? Yes. And if this interface do not join the multicast group, it means on this interface router neither send the multicast or neither receive the multicast. Getting my point, everyone? Can you tell
Yes.
me? Yes. But this router is sending the packet. This router is getting the multicast packet. But this router never accept it. Why? Because this interface do not join the multicast group. Done, everyone? Can you tell me?
Yes, sir.
Do you guys understand? Yes or no?
Understood, sir.
Yes, understood.
Anyone have any question? Abel, I hope you are enjoying. Abel, you enjoying? Okay. Let me check one command. I don't think it will work or not. So IP interface give 0 by 0. Everyone please focus here and try to find, is you guys getting multicast? Check, do you guys getting multicast word here?
Yes, the dawn. Multicast passage, multicast passaging, distributed fast.
IP multicast forwarding switching is disabled. IP multicast deciding is disabled. No, no, no. This is different. Okay, you guys can check in GNS3. Maybe you guys will get the result there. You guys will get multicast enable like this. Okay. So there you guys will find multicast is enabled. Are you done, everyone? Yes or no?
Yes, sir. Sir,
Yes.
can you run the other command which was not working before, not showing any data, any details?
Okay.
Okay, something IT protocol was there.
No, none of the command is stacking. Yes, there is limitation in the packet tracer. Okay, now, but you can run. You guys will get done. So this router is not receiving the packet. The reason is, what is the reason?
Multicast
Multi-
is
Yes,
disabled.
disabled. Getting my point, everyone. So let's suppose I on router number 2, I run the command router OSPF 200 here I'm writing. It means process ID is same or different? Different. Network 10.0.0.2 0.0.0.0 and I mentioned the area what?
Zero.
Fine. Oof. Which one? This is the hello, na? Everyone. And this router is now receive. And this router forward. Are yes or no? Everyone, tell me.
Yes, sir.
Yes.
This router receive and forward. Like this. So I hope now you guys understand. And when you, how can you check neighborship is established or not?
So IP OSPF neighbor.
OSPF neighbor. When you check, this is the neighbor ID. What is this? We will discuss these things later. State, what is this state? We will discuss these things later also. I told you now there is one router will become the master. That is called DR.
DR, yes.
Among this one and this one router will become the leader, and that is called DR.
DR.
Okay. Okay. So that is the dead time. It means this router 37 seconds left. Address is this one and gig 0 by 0. It means when I write this command on R1, it means 10.2 is the neighbor, and this neighbor is connected on which interface?
0/0.
Done na? So why I am telling you now, we confirm here I configure router OSPF 100 and here I configure router OSPF 200. Process ID is different, but still neighborship is formed. First thing. Second thing, if you write the command router OSPF 100 only, router never generate the OSPF any messages like hello messages. Getting my point? So router will always generate the hello messages, or router will always accept the hello messages when you write the network command. Are you tell me yes or no? Yes, na? Everyone.
Yes.
You guys understand? Yes or no? Yes?
Yes,
For
sir.
example, if I configured here, for example, router EIGRP and here I write 100. It's the same command, network 10.0.0.1 and press the question mark. What is this? Wildcard 0000. Done. No auto summary exit. Do show IP protocol. I run this command to check which protocol is configured. Previously we configured the OSPF. Yes or no? Yes, na?
Yes.
Everyone. Now I configured what? EIGRP. Tell me. Yes, na? I configured EIGRP. Done. Now here I configure. On this router I am configuring router EIGRP. Now configuring 200. Network 10.0.0.2. No auto summary. That's all. So it means on router number 2 I configured EIGRP. So what I did, guys, here we configured EIGRP 100 and here I configured EIGRP 200. Yes or no? Everyone, yes?
Yes.
Now I am checking the neighborship. So IP EIGRP neighbor. We are not getting the results. What is the result? IP EIGRP neighbor for process 100. It means you guys will get the neighborship only and only when you have a AS numbers,
Same.
AS numbers 100. I'm not getting the neighborship. It means between R1 and R2 neighborship is not established. They're getting my point, everyone. Understand now?
Okay.
Yes.
That is the thing I want to show you. And everyone.
Yes.
Yes, got it.
Conf T. Here I am writing router EIGRP 200. One more thing you guys can see. On this router, I already write router EIGRP 100. Yes or no? Are you tell me? Router EIGRP 100.
100.
Now I am writing router EIGRP 200 and router is taking this command. It means on the same router I can write multiple AS number for EIGRP. Yes or no? Yes?
Yes.
Yes, na? Same thing in case of if I am writing router OSPF 100. I am able to write exit. I am writing router OSPF 200. I am able to write. It means on the same router, I am able to write multiple process ID. Yes or no?
Yes.
In case of OSPF as well as in case of EIGRP. But see, router BGP 100. Done. Exit. I am writing router BGP 200. Getting the error. BGP is already running AS100. So what is the conclusion? Conclusion is on the same router, you can run multiple OSPF process ID. On the same router, you can run multiple EIGRP AS number. But on the same router, you cannot run multiple BGP processes. Getting my point, everyone? So I hope you
Yes.
guys understand the difference. Done? Or tell me.
Yes, sir.
Yes.
And what we get, if you configure the same process ID or either you can configure the different process ID, you can easily form the neighborship in case of OSPF. But in case of EIGRP, between the different AS, you can't form the neighborship. Yes or no? Yes.
Yes.
If you want to form the neighborship, you need to configure the same AS number. Done na, everyone?
Yes.
Tell me. Okay.
So, sir, how different A's communicate between each other?
Sorry?
How different A's communicate between each other?
How different AS will communicate with each other, we need to
Through
redistribute.
EGP.
If you want, see, basically, if you want to make communication possible in the two different AS, there are two methods. First one is redistribution, and second one is EGP protocol, that is BGP. But in real scenarios or in maximum scenario, we are using the BGP, EGP protocol. Basically, if you are using the redistribution, definitely the network will be more complex.
Complex.
So that's the
So
reason we are
it's advised if you want to communicate with two different AS number, then the best thing is to use EGP, to use EGP protocol.
Yes.
Yes.
Understand?
Yes.
Yes.
Now that EGP protocol, as I was saying that which protocol is the EGP protocol we can use for two routers with two different AS number to communicate. Is that not BGP? That's border gateway protocol, right?
We are using only BGP for different days communication.
Okay, only BGP. Okay.
Yes.
Okay.
And I hope you guys understand the process ID also, right now, everyone? Tell me. Yes,
Yes,
no?
sir.
Yes.
For example, I'm just telling you, for example, let's suppose here we have a router like this, and here like this, and here you configure the OSPF, right? For example, here you have a 10th network, and I'm not configuring, this is your task. This is here you have a 20 network, and you want the neighborship between here, and you want neighborship here. Are you getting my point? Yes or no? Yes, na?
Yes.
If I write the command to show IP OSPF neighbor, I am getting the result. It means this router is already neighbor with this router. Yes, na, everyone?
Yes.
Yes?
Yes.
Okay. For example, on this interface gig 0 by 1, I'm writing IP address 20.0.0.1 255.0.0.0 and no shutdown. Done. Here I configure gig 0 by 0 IP address 20.0.0.2 255.0.0.0 and no shutdown. Done, everyone. Done na? Okay.
Yes.
On this router, I am configuring router OSPF 1 or 2 I already configured, right now. Sorry, 100, 200 I already configured. I configured here 300. Done. Network.
Yes.
Here we are running the 20.0.0.2, I think, right?
Yes.
0.0.0.0 and area is 0. So we configure the do so IP protocol. I configure the OSPF 300 process ID and advertise this network in area 0. Done na everyone. Now on this router, to show IP protocol, we are running EIGRP 200. Remove the EIGRP 200. How can we remove? No.
EIGR 100.
To show IP protocol.
EIGRP 200.
Multiple BGP is also running. 200 is also running. Okay, no problem. I think on here we are running the OSPF 100 right now, everyone. Yes or no? Okay. Router OSPF, I am running the 300. Are done na everyone?
Yes.
On this router, I run the router OSPF 300 and here I am running the router 300. 100 already running here, right now, everyone? 100 already
Yes.
running here. Okay. Now I am writing the network. What is the network? 20.0.0.1, 0.0.0.0 and area is 0. Done na everyone? Are you tell me?
Yes, sir.
IP. You are getting one message. What is this message? Process ID 300, neighbor is loading to full. It means neighborship is now established. Show IP OSPF neighbor. I write this command. See how many neighbor is there? One neighbor is with which router? This router. Yes, na?
Router 2.
One neighbor with this router and this neighborship with this router.
First
Yes
router.
or no? Are you telling me yes or no? Yes, na? Everyone.
Yes.
So I hope now you guys understand what is the exact use of process ID. Right? On the same router, I run two different process ID. Right? In
Yes.
process ID 100, I establish the neighborship with this router. And on the different process ID, I establish the neighborship with this router. Are you done na everyone? Yes or no? For
Yes.
example,
Yes.
suppose if you are working in the real environment, and let's suppose if you want to change any configuration, any policy or anything between this router and this router, so you can run that any command in process ID 100. Yes or no? Everyone. Are you done
Yes.
na? And let's suppose if you want to change something, you can run in process ID 200. Configuration will be separate because by the help of process ID, you can just separate the local configuration. But for example, if you run the router OSPF 100 and in 100, if you configure everything and if you want to change anything on this, on between this one, on this link, you can't. Whatever you will implement in router OSPF 100, this will implement overall.
Mhm.
Are you done na everyone? Understand?
Yes.
So that is the way, that is why basically we are configuring what? Process ID. And that is the use of process ID. We can separate our local configuration. Done na everyone? Yes or no? Are you tell me?
Yes.
Yes.
Now, for example, you are on this router. I am writing enable and I am writing show IP root. See, you have all the root here. Yes or no? You have all the root here. What I am trying to show you here, ping. Let's suppose no, leave it right now. We will discuss these things later when I teach you something. Okay. So I hope now, till now, You guys understand what we discussed? And now, everyone, tell me.
Yes.
Yes.
So